Some quick terminology about parabolas. When you graph a quadratic equation, you always get a parabola. So standard form of a quadratic equation is y is equal to ax squared plus bx plus c. We'll look at a couple equations soon. But there's the axis of symmetry. Axis of symmetry, which is the line, symmetry, which is a line where it's symmetrical. Here it just happens to be at x equals 0. So for this one it's x equal to 0. There's the vertex. And that is the topmost or bottommost part of a parabola. Here it's at 0, 0. And then there is the domain. Although it tapers further and further in, the fact of the matter is it's going to still go through infinity. So the domain is always going to be infinity, infinity. Okay? So the range. The range for this particular one is going to go in through infinity above 0. So you're going to say y is greater than or equal to 0. It's going to go on forever above 0, and including 0. So let's go and try to graph this parabola, and I've got to make it equal to 0 because you ask yourself where, because we're trying to find, when you graph, okay, let me back up. When you graph it and you find your zeros, those are actually the y-intercepts. Because if you have y is equal to, let's say, x squared plus 4x plus 4, when I solve this, if I put 0 in for y, that's going to be where my parabola crosses through the y-intercept. In this instance, you're going to get 0 is equal to x plus 2 squared, and then take the square root of both sides and you've got x plus 2. So that means that your parabola is at -2, and your vertex is going to be hitting at -2. Now if that confused you, don't worry. I'm going to clear it up with this problem, hopefully. So my y is going to be 0. Let me get rid of this mess. And my y is going to be 0 up here, because what I'm going to do is I'm going to add 2 to both sides, and conveniently we have it set up equal to minus 10 plus 24. Conveniently we have it set up equal to 0. So now we can easily find our X-intercepts. So remember the protocol. 2 sets of parentheses, break up your ends, figure out your signs. We've got a plus here. That means we either have 2 positives or 2 negatives. Look at this sign, 2 negatives. Excuse me. So what times what gives me 24? That adds up to 10. Well, that's easy, 6 and 4. I say adds up to because their signs are the same, we're going to wind up adding them. So that means we have 2 values. We have 2 x-intercepts, in other words. Our value of y for x-intercepts are always 0. So I'm going to put that in. And if I do x minus 6 is equal to 0, n is equal to 6. X minus 4 is equal to 0, n is equal to 4. We've got 6, we've got 4. Let's graph it. I'm actually doing this downstairs. I don't know what we call this room, but there are people walking by that are probably thinking I'm talking to my device and probably think I'm a little crazy right now. 1, 2, 3, 4, 5, 6. So we're at 4 and 6, and this is where a parabola is going to cross the x-axis. Now to find the axis symmetry, you do x is equal to negative b over 2a, and be mindful that well, I already wrote it up here. This is the standard form. So you're looking at the coefficients. You're looking at the number in front of the variable. So negative b over 2a. Let's go back. And equals, so negative 10 is positive 10. So negative 10, positive 10 over 2 times 1 equals 5. And we just found that our axis symmetry is at 5. And that would make sense. That's where it would be symmetrical. Now we have to find our vertex, and then we can plot this. To find the vertex, I'm going to put 5 in 4, my x value. In this case, they use n to make it confusing, I guess. And now we're going to solve for y. So we're going to put in 5 for n, 5 squared minus 10 times 5, excuse me, plus 24. Let's go ahead and solve this. We've got 25 minus 50, so we've got negative 25 plus 24, and 25 minus 50 is negative 25, plus 24 is negative 1, and that's our y value of our vertex. Of course, our x value of our vertex is 5, so that means our vertex is happening at, I should do equals, it's at 5, negative 1. So I'm going to plot our vertex here at 5, negative 1. And now for our parabola, and there it is.